Equivalent polynomials, right? We simplify polynomials and we get some expression. So the expression which we get after simplifying the polynomial is always equivalent to the original polynomial. So, and there are, sometimes if two polynomials are given to us and we need to find whether they are equivalent or not, how will you find it? One way, of course, is you can simplify both of them, and if they result into the same thing, then they are equivalent. Or what you can do is you can graph them, and if they produce exactly the same graph, then also they are equivalent. Or you can test them for a couple of values. Today, in this video, we will see how to determine whether the given polynomials are equivalent or not. Let me give you a concept. Let's say we have an equation of line x plus 2y equals to 6, and another line y equals to minus half x plus 3. Do these two lines represent the same line? Are they equivalent, or are they equivalent polynomials? This is what we need to see. So what we can do is we can simplify this or find what y is from the first equation and then check if we get the same result. So we can take x this side, so we get 2y equals to minus x plus 6, and dividing by 2 we get y equals to minus half x plus 6 divided by 2 is 3. So we see they're exactly same equations, and if we plot them we will get the same line, right? So, or you could have straight away plotted them. So to plot them, what will you do? We can use y-intercept and the slope. Let's say this is my point 3 and rise over run is minus 1 over 2. So you can go down 1 unit and 2 units to the right will give you next point. And so join these points, you get a line. So this line represents both the equations. Since they have same graph, we can say that these two polynomials are equivalent. Okay? Now, we will solve some problems which are here to check whether they are equivalent or not. So question number 1 here is, are the following polynomials equivalent? So we got two equations here. Now this is a tutorial sheet. Actually you can stop the video here, take a good look at this and solve both sides. In this case you can expand and simplify the right hand side and check if you get a cube minus b cube. If you do, then they are equivalent, otherwise they are not. Now similarly the other problem, which is t plus 5 whole square equals to t square plus 25. Here you can expand the left side and check, do you get the same result or not? You can also test it by plugging in different values of t. For example, you can test both sides for t equals to 0, 1, 2. If you get same values, they are equivalent. If not, they are not equivalent. Correct? Now, or you can stop the video at this time, do it yourself and check with the solution which I am just going to give you. Okay? Now here is how we can do it. So let me do the first one for you. We'll go with the right hand side. Okay? So right side can be written as, we'll expand it. A times a square is a cube. We'll multiply this. Simple distributive property, right? A square b. This will give you ab square minus b times this is minus. Let me write a square first. A square b minus b times this is minus ab square, and minus b times this is minus b cube. Okay? Now a square b, let's see the terms, plus ab square and minus plus a square b and minus ab square, they will result into 0, correct? Similarly, plus ab square and minus ab square will result in 0. So we finally get a cube minus b cube, correct? So since left side is same as the right side, both are equivalent. So we say these two polynomials are equivalent polynomials. Let's check this one. Here I can expand the left side, t plus 5 whole square, and check if I get the right side. Another way to do it is to plug in the values. So let's say let t equals to 0. In that case, let me write 0 here and test left side. So I get 0 plus 5 square equals to 0 plus 25, and I get 25 equals to 25. Well, that's correct. But you know what? Two polynomials, for them to be equivalent, we should test many points, because t belongs to a set of real numbers. They could be same at one point. So let me test another value. Let's say t equals to 1. In that case, for t equals to 1, I get 1 plus 5 whole square equals to 1 square plus 25. Now 1 plus 5 is 6, and 6 square is 36. Here 1 square is 1. 1 plus 25 is 26. So we say these are not equivalent. To show that the two polynomials are not equivalent, it is enough to prove that they are not same for one point. Then also you can say they are not equivalent. But to show that the polynomials are equivalent, you have to test for many points. The best strategy could be expand and then show. Well, let's expand this. T plus 5 whole square. T plus 5 whole square is t plus 5 times t plus 5. Now that means t square plus 5t plus 5t plus 5 square, which is t square plus 10t plus 25. So do you see the term? 10t is missing from the right side, and therefore they are not equivalent. Correct? Now there are two more problems here on this sheet. This sheet I've tried to get some of the very good problems for you. So these problems are on thinking and problem solving and communication. Now look at this problem. This says determine two non-equivalent polynomials fx and gx with y-intercept of 2 and f of 3 equals to g of 3. What they are trying to say is you have to find two non-equivalent, that means the polynomials are not exactly same, they are different, but they have 2 points in common. One common point is the y-intercept, and the other one is their value at 3. Now this is how the two polynomials think about it. How to get the solution? Could be, we could take any two polynomials, right? It is like drawing two polynomials and finding point of intersection. So that could be a kind of solution, right? It is something like this. Let's say we have one parabola and one line, right? So at these 2 points, do you see? They may intersect and their values may be exactly same. So that's the kind of problem it is, and we are looking for something like this as a solution too. Now since we know that the y-intercept is 2, then, and let's assume that our polynomials represent straight line or a parabola. So in that case, let me assume that my polynomials are, since it is a straight line, let me write this as y equals to mx plus y-intercept of 2. Let this be my straight line. Correct? Now the other is a parabola. So let me write that parabola as fx equals to, so what could be the y-intercept is 2. So let's take it very simple. X square plus 2. So because 2 is a y-intercept, x could be anything. Now second condition is f of 3 is same of g of 3. So what we will do is we will find the value at 3 for our first equation, which is a parabola. So that means 3 square plus 2, it results in 9 plus 2 is 11. Correct. So we want this point to lie on our gx. Is it right? So we'll find a particular slope. So I'll substitute this value of f3 here. So y value should be 11 and x value should be 3. So we'll do 11 equals to 3 times, and x value is 3, and we have to find slope m plus 2. Now we'll solve it. We'll take 2 on this side, and in that case it will be 11 minus 2 equals to 3m, or 9 equals to 3m, or the slope of the line is 3. 9 divided by 3. Therefore, what is our gx? I can write gx as equals to m is 3. 3x plus 2. Do you see that? So the answer for us is that fx equals to x square plus 2 and gx equals to 3x plus 2. So these are two different polynomials, right? One represents a line, the other one a parabola, but they have 2 points in common. One, their y-intercept, 2, and then if I plug in 3 in each, 3 square is 9, 9 plus 2 is 11. 3 times 3 is 9, 9 plus 2 is 11. So their value at G3 or F3 is equal to how much? 9 plus 2, 11. Do you see that? So that's how you can find equation of two different polynomials which have same common points, correct? Now we go to the communication problem, question number 3, correct? Here, explain how can you show that the two polynomials are equivalent. Well, during the solutions of question number 1 and 2 in this video, you learned many things, and from there you can write down the answer for this question. When are the two polynomials equal? Well, they are equal if you simplify their equations and they result into exactly the same equation. That's one condition. Second could be, you could test them for a lot of values. That is, fx equals to gx for all their values in the domain. Well, the domain of polynomials is all real numbers, so you can practically never test all values. Well, if you test 4 or 5 maximum without getting a miss, then they are same. But to prove that they are non-equivalent, it is much simpler. Just test couple of values. If even the first value give you different answers or different value at input point, you get different output point, then they are not equivalent polynomials. Thirdly, we saw that if you sketch the graph of the two polynomials, and if the graph is exactly the same, then the two polynomials are equivalent, correct? I'll appreciate if you do these problems yourself and then gain some confidence, okay? Try doing them once again, okay? Thank you.